Hey everybody, welcome back. So we were just working with sentiment analysis, which is pretty cool. You can get a lot of interesting things out of sentiment analysis. But it's important to also understand the limitations of a technique like that. And a lot of the limitations of sentiment analysis come from the fact that it's a very simple technique being applied to a crazy complex thing, human language. Right? Crazy complex human language. Anything where we say that one given word always has a particular kind of emotional valence to it, well, I'd be pretty sure that's not the case. Let me give you some examples of that. So, my favorite example is the word dude. Let's not even get into the fact that you could have words that have different meanings for the same actual written word, right? We know that happens in language. But let's just take the word dude as it is used, as it means a person, generally used as an informal piece of address, and usually by Americans. All right. Dude, 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 dude. Those all have very different emotional valences, right? Dude! Okay? You can do a lot just with your tone of voice. This is all the same word. It can be a very emotionally loaded word. It can have a true, sentiment to it that we would like to be able to pick up, but we're not necessarily going to be able to. So, with something like that, we have a situation that we're not going to be able to accurately recognize the context, from the context necessarily, what the right sentiment of this word is. Okay, so that falls roughly under this category of context in language and contextual meaning differences, or also you can talk about that as being part of the pragmatics, where the tone of address indicates something about meaning. This is a part of linguistics, is pragmatics. As I mentioned, we also have homonyms, where the same word as it is written actually has two different meanings, or it's really two different words. And an example of that is the word bad. Bad, in a sentiment analysis, you would think it might be bad, right? It might be a negative sentiment. But we also have a very long-standing history of the use of the word bad to mean good. For several decades, it's been true in a lot of kinds of slang. So that's so bad, dude, right? Means that's really good. Wow. So we have issues like that, where we have homonyms, we have contextual kinds of meanings. We also have problems with parts of speech. So if we're going to say, we're going to use the word ride. Ride is a verb. We ride. Okay? But you can also say my ride. Okay? Like I have a car. This is my ride, dude. And so you might find that anytime you're using some sort of dictionary lexicon-based approach, that you may not be able to accurately capture what the actual sentiment or any other linguistic element truly is, because language is weird and varied, and you get different results, even with the same letters on the page. Okay, so we know that's a problem. We're in a situation where we're not going to be able to necessarily accurately do whatever natural language processing task we want to do. That's okay, right? What we're hoping for is that we've got a good enough situation. My point in what I'm trying to do in pointing out the limitations is to just make you aware of the fact that any analysis you do with these kinds of techniques, there's errors in it. What you're hoping for is that, you're capturing 80% of it right. And if you capture 80% of it right, then maybe the parts of your analysis where you find something interesting are true and not just a result of you misunderstanding the language as it is written with your computer algorithm. Okay, so beyond the difficulties of human language and the way they mess up our algorithms, we also have issues where if we want to do a task which involves recent language. Slang in the last couple of years, many of the tools built for natural language processing, 12 years ago or 10 years ago, they're not going to capture modern slang. So if the point of your analysis is to do something, I don't know, with social media words that are being used in the last couple of years, you've got to be able to recognize things that are brand new, like thick with two C's, or shade, throwing shade on somebody, or a clapback. These words didn't exist 5 years ago in that way. So, if your lexicon is not up to this task, you might not see these kinds of things. You might miss a lot of the sentiment or whatever else you're doing. Right. So it's important to note that there are multiple lexicons out there, and you're going to get different results with different lexicons. So once again, the point of throwing these limitations at you is to understand that you're going to be operating in a realm where you're seeing, am I 80% correct? And if so, is what I'm seeing the truth? I hope so. All right. So let's take a look at another completely different kind of analysis. Sentiment analysis was looking at just looking up from a word what its valence is, but we might be interested in other things, not just the emotional valence of something. We might be interested in, for instance, what is the topic of a document? What are the unique elements of this document that set it apart from all the other 100,000 documents I have in my collection? So this brings us to a new tool, term frequency inverse document frequency. As you might guess from the hyphen in here, TF-IDF is an equation, a software tool, which has two parts to it. It has the term frequency, which is, how frequent a given word is. And it has this inverse document frequency, which is something close to how unique is this document in having this word. Okay, let's take a look at it. So, term frequency, as I said, how frequently it occurs in a document. This is literally just, you can say, it's a count of the number of times the word of interest is occurring in the document. Okay, it may actually be normalized by something like, how many words are in the document, but, fundamentally, this is a count of words. So the inverse document frequency, there we go. Get out of my face. All right. So the inverse document frequency is how important this word is to the document. So let's zoom in. Let's start doing some math, right? This is maybe the first math I've done in the course. Ooh. If so, it's exciting because it has a natural logarithm. And the reason I'm showing it to you is that the natural logarithm is very, very important for understanding this whole idea. So a natural logarithm of x here on the left-hand side, you'll remember, approaches negative infinity as you get close to 0. And it approaches it sharply and drops steeply as we get close to 0. The natural logarithm is 0 at the value of 1. And then it goes up here and it approaches 1 very, very slowly. Okay? It asymptotes. So it's got to go pretty close out here to infinity to get out to a largish, close to 1 number. All right, so let's look at what's inside the natural logarithm in the math term here. Okay, so it's the number of documents in our data set. So let's say that's 100,000 documents we have in our data set. And underneath is the number of documents containing the term. So what happens if we have a term which is in every single document in the data set? Well, 100k over 100k, well, that's 1. So that's a natural log of 1. So we get a value of 0 on this IDF term. In other words, we do not care at all about a term which is in every single document. It's not unique. It doesn't tell us anything important about the document. What might be a word that we might see that would be in every single document? I'm going to throw that question out to the class. What would be a word we would see in every single document? Yeah, short-haired kid in the middle row. Yes, the, those are great ones. What else might we commonly see? Yeah, Lebowski. Yes, indeed. Things like 1, 2, okay, numbers might be very common in a lot of documents. Anything else? Yeah, Bueller, front row. Yes, that's right. Like common names like Joe or, Alice or something like that. Depending upon the nature of what the documents are about, you could see stuff like that. You're absolutely right. Okay, but the point is that all these things, these function words like and the and one and two and modifiers, at really common adjectives, right? Things like that. They don't tell us anything about what the document's about, so they don't help us understand the document, right? So we want to get rid of those. We don't care about them, and that's why we're going to end up in a situation where if most of the documents happen to have this, that we're going to end up in a value close to 1 here, and that means we're going to get a term which is close to 0, which eliminates the importance of that term from us caring about it, right? What happens, let's go check something else. What happens if there are way more documents than there are, if there's very few documents that contain the term. So we have 100,000 documents, and say we only have 1 or 2 of these guys which actually contain this term. Well, what we're going to have happen is, right, so if this is like 100,000 over 100, then this value goes to 1,000. So we're way out here. We're going to go up on the asymptote, and we're going to be, somewhere out here, which is a positive number which is less than 1. Okay? So the bigger this ratio in here, the higher the number inside the log, the closer we get to 1 on the inverse document frequency. Okay, so a rare word, one which is only in just a couple of things, a couple of documents in our collection, is going to be of great interest to us. So this is the whole thing. We have the term frequency, which is really just the frequency of the word of interest. Okay? And then we have the inverse document frequency, which we've already discussed, which has this nice logarithm to it, which is going to force us to make sure that we only care about stuff which is rare in terms of what document it pops up in. Right, so we can use an algorithmic tool like this to understand things about a collection of documents. We could, for instance, take a look at what is the most important words in your class responses, right? So let's revisit your midterm class responses. When you said the things that you were least or most looking at in the class, most looking forward to, least looking forward to, right? What things were unique to the least case, to the things that you didn't like? Well, the terms that are unique to your responses were the quizzes, tedious, right? Readings, apparently. Focus, I'm not sure exactly what the hands bit or the person does, but like you can get some sense that these are negative words, right? Quizzes make people nervous, work is tedious, nobody likes reading all that stuff. So these are words in negative responses that you gave that are unique to negative responses and didn't occur in the positive responses in the other document. Whoops. So All right, what are unique words on the right, on the most engaged kind of stuff, on the positive responses? Well, scientists, life, I guess you like the slides pretty well. I guess you love something about the course. The Facebook stuff was apparently quite popular. All right. So these are words that are falling in positive comments. They're unique to the positive comments. They don't occur nearly as much in the negative comments. Okay, so we can use this on, say, the works of very interesting people, right? So, oh, my slides, please work. There we go. So if we look at all the words written by Galileo Galilei and Albert Einstein and Nikola Tesla and Christian Huygens, famous scientists of yore, we can give all their words that were written down in their various academic papers and in their letters, and we can do an analysis of term frequency, inverse document frequency. We can identify what words are unique to Nikola Tesla that were not used by Albert Einstein or Christian Huygens. So, Nikola, being the inventor of many cool electrical things, he has words like bulb and coil, wire, current, right? Einstein, being a physicist, has his famous theories like relativity and gravitational, things like that. Christian Huygens, being, quite the astronomer, we have refraction and ray, spheroid. These are all things that are obvious for an astronomer, but not so much for, say, a physicist. And Galileo, he was also an astronomer, but one that was a little bit more concerned with the nature of the movement of the planets than Huygens, who was a little bit more concerned with understanding the telescope and stuff like that. All right. So here we are. These are the most unique words for a given scientist. I am not going to run an iClicker question on this because I've basically just talked it all the way through, right? Albert Einstein's most unique word that's unique solely to Einstein is no surprise to you. So when would you use a tool like TF-IDF? TF-IDF. I can't type up there. See, that would be an unusual term, TD-IDF. I'd be the only one ever using it. So it would have a high inverse document frequency score. All right, so when do you use this kind of software tool? Well, you can use it to look for things that are unique to a document if you look, like we showed you, at the high end, right? The highest score is going to be if you have documents that are about individual customers, right? Then the unique words that are unique only to that customer, and again, squashing all the ones that are just function words and we don't care about them, those might be unique customer needs or unique features of this customer's account or something that your business might care about. Okay, if you want to try to understand what the topic of something is, you can look across many similar things like subreddits or Discord servers or documents, pages in Wikipedia, and all right, thanks, Magic. We can look at unique cats too. All right, Magic, does that make you feel better? All right, so we can find whatever the unique topic is by finding the most important high-scoring terms. And we could cluster things up that have similar high-scoring terms and say they all belong to the same topic. You can also use this as a search tool, right? If I'm saying search for topic X, well, you could pull up the document which has the highest TF-IDF score for topic X. That might be the most relevant one for this search. And in fact, there's a lot of similarities between TF-IDF and Google's PageRank system that they originally started with. There are mathematical similarities between them. So on the flip side, on the low score, right, the things that have the closest to 0, those might be stop words, words that you want to get rid of and not pursue further. So that's nice to be able to find out what stop words might be, so you can just, yank them out of your corpus and stop doing analysis on them. You might also find things that are very common across customers, the most normal customer case if you're looking at, some documents about them. So, all right. Let's stop there. We're going to do another short break, and we'll come back and take a look at some visualizations. Bye for now.